Hey guys, and thanks for joining for another video. This one's a bit different. I thought I'd start recording some of my kind of raw, uncut sort of practice sessions. I work as a software engineer, which means I code in multiple languages, and occasionally you find yourself working in things that aren't Python, so it's kind of nice to kind of come back and revisit it. So today I'm going to be going through some questions on Edabit here, which is quite an interesting site. It's kind of like a watered down leak code. I plan on doing a load of Edabit, a load of leak code in the future as well. It depends on how I'm feeling really. So I'm going to do 4 or 5 easy questions on Edabit, and I'm going to, I might do a quick cut in between the questions to grab some more water or coffee. But when I'm solving them, I'm just going to leave it running, so any mistakes I make, I'll leave in. So if I make a mistake, you'll see it, and then I'll try and correct it. But the whole idea is just so you can see my thought process behind solving these. And I'll leave a link to the site as well in the description. So let's take a look. I'll show you the basic run through. Basically, you get your instructions here. You get your code where effectively you have to, a bit like leak code, you have to sort of write your question, or so write your solution underneath here. There's like comments, resources, etc. But what is kind of cool is you actually get the unit tests, so you can kind of play around with these before you hit run. But yeah, let's start the first one. So what do we have? Create a function that inverts the RGB values, so red, green, blue values of a given tuple. What does it mean by invert? So we're just flipping them in this case, it looks like. It looks like we're just doing, yeah, so the max value you can have is 255 in a given position. So this is just, it's just 255 take away each thing. If that is the case, this is a pretty simple question, and we should be able to solve this pretty quickly. That's a nice easy one to begin with, right? So let's just quickly pinch this tuple here, and we'll stick this guy here. And what I'll do, I'm going to look at the code. They call it RGB. Okay, so I'll do mine in the same, just so I can kind of bring this guy into the function. So what I want to do is effectively do 3 things here. So I'll use 255 take away something, 255 take away something else, 255 take away something else. So to get this guy, it's going to be RGB of indices 0, this here. I make it look neat at least. And then same for this guy, space, and then this, and this, minus this. Let's not do return, obviously right now we're not inside a function, let's do z, and we will then print off z underneath and make sure that we got the right stuff. Okay, right, yeah, 0, 1, 2, that'll help. Here we go, 90, 85, 34. That's quite easy, so we can do return here, and I'm just going to pinch this and stick that here. Sometimes the indentation's a little funny, but we'll see what we get. And test passed. So when you hit run on this, it tells you like, yeah, you passed all the tests. There's a lot of unit tests. So kudos for writing that question. Submit final, and this should be lovely. We've got some XP, whatever that means. Okay, next challenge. Let's see what we get. Okay, our next one. Oh, it's a bit more wordy, this one. Okay, so you tend to find with these, like I call these story questions, but it just means that there's a lot of kind of faff and a lot of wordage around what's a fairly simple idea. So almost what you can do is kind of skip and look at the examples and see what's the output. But yeah, we'll do it properly. So when resistors are connected together in series, the same current passes through each resistor chain. The total resistance must be equal to the sum of all the individual resistors added together, that is, RT is equal to R1, R2, R3. So we're going to be doing some adding. Okay, create a function that takes an array of values, so I assume that's this, and calculate the total resistance in ohms. The ohm is a standard unit of electrical resistance. Okay, that's kind of pointless, it doesn't really matter for the time being. This looks like we're just adding this and putting it into this string. That's quite easy. So we're going to be using an f string for this. We're going to be using the sum function. So we're going to do the sum of this, stick that into an f string, and that's it. Let me get rid of this just for a second. Okay. Right, okay. So, and what I'll do the sort of same thing again. Actually, what do they call the list? They call it LST. Original, that's nice. LST is equal to a list here. And let's just do, I think what I'll do print, and then I'll just sort of switch this guy out. So you can do this kind of like in one thing. So we can do an F string or a format string. I mean, funnily enough, actually, I used to have Edabit not like F strings. I don't know, that's because it's sort of stuck in Python 3. So tell you what, we'll do a format string instead. That's where you do some kind of string, you do dot format, you do some stuff in here, and then basically whenever you have this in your string, effectively says, okay, whatever's passed into format, put into this placeholder. So we know we need to have like something space ohms, and then whatever I put in this is going to go in there. So this should just be sum of LST. So that should probably do it. 15 ohms. Cool. Remove this here. I'd normally do this as an F string, but I'm pretty sure Edabit's stuck in like an old version of Python. I've tried to do these before, and it's not liked it, so make sure I count this right. Two open, two closed. Yeah, I think that's good. Don't forget to indent. We'll see if this accepts it. It should do. Okay, my bad. It wants OHM. That's interesting. Okay, I see. Let's see. So I presume what they've got, there's one that says, look at that. So if it's less than 1 ohm, it's just OHM. Oh, interesting. Okay, so in that case then, bring all this back. What we'll do is we'll have this as like just call this txt here. Now, calculating the sum twice is not an ideal solution. But what we can do is do like an inline conditional here. So we can do OHM if sum. So I can like dynamically build this string basically. And I'm pretty sure, let's see when it has OHM. It's only that it's 1 or less, isn't it? Yeah, so 0.9 here and 1 there. So we want OHM if it's 1 or less, basically. So OHM if some list is less than or equal to 1, else OHMS. And we'll call this text here. And that now means we can do a second placeholder, sum of list, txt. And that should do it. So please Edabit, accept this one. Right, yeah, of course. Very silly. I can always tell when I'm tired doing this. No, don't save that. Let's just check. And test passed. Lovely. Submit final. And this should do it. Oh, lovely. Okay, that wasn't too bad. Let's do 2 more. Okay, here's our next question. Let's sort this list. Lovely. Create a function that takes a list of numbers LST, a string S, and return a list of numbers as per the following rules. So ASC, store in ascending order, so that must be this guy here. Okay, so if you get that, it's a normal sort. And this DAS, sorting backwards. Okay, so you can use list.sort. Actually, you can do return sorted list and then reverse equals, and then the true or false will depend on basically what these are here. So if it's none, we do. Okay, so if it's none, we just do without any modification at all. Okay, so we can basically say, if this, let's see where it is. If S is none, just return it as is. Else we'll return the sorted list here. So let's pinch our test cases. I wonder how many there is. That's not too many. We'll have a go at this. Let's remove this guy from the previous. And this one's a bit more interesting, isn't it? Did I not copy it? No, I didn't. Let's steal this here. And you can sit up there and I'm using that a bit. That's a little bit bigger. Okay. And you know what I'll do this time? We'll do the function from scratch. So we'll take our code and we'll do this here. Just because this one's a little bit bigger and it kind of has more kind of pathway through it. depending on what S is, it's going to kind of negate, we're going to go down this line of control flow or the next. So I will do, let's see, I'm going to actually steal probably all of these from a function call. Do ellipses like this here, that kind of counts as space. It's like the same as writing pass, by the way. So I do that if you kind of just leaving a function unattended for the time being, then that's fine, you can leave that up there. And we will do a hashtag here, hashtag there, and see what we get. So yeah, well, first one's nice and easy. So we'll do if S is none, return LST. So we should expect to see this guy in here. So if we hit run, let's see. Oh yeah, I need to. Normally the examples don't print them, but of course if we want to see it here, we need to print it. If S is none, return LST. Oh, interesting. So they've done it. Normally they've done it like. So in that case, if we'll do if S is equal to, if it's when it's the none, like to answer the question would have been nicer like that, but it's none as a string, so we'll do that. Okay, if S is none, return this here. And now we might just do like an inline conditional to get this here. So suppose I just had X is equal to ASC here. And what we can do, because we basically want to do effectively something like this, return the sort of LST reverse equals, and then like whatever here. And of course, if you could do an if else to say like return, if this is ASC, return it with reverse equals false. If not, but we want to be a bit smarter about it. So what we can do is we do an inline conditional. So we'll do true. So this is the reversing of true. So basically true if this. So if X is equal to DES, else false. So you could do it like that. And to be honest, we could even do it even easier than that. So we could just do a simple, that'll be like a kind of like a ternary one. We could just do y is equal to, let's see, x is equal to, let's do ds here. So we can do it like this structure. So y is equal to, let me put some parentheses here. So if I do y is equal to, x is equal to this, basically we evaluate and say, well, is x equal to descending? And if I print y, we should get a true or a false kind of result, and we get false here. So what we want to do in this case is effectively do like effectively this up here. So when we do reverse is equal to, actually make sure we're checking the right one here. So do s, probably best off doing this in parentheses here. So we want to return. So this will be, let's see, so we want this to only be true when we're reversing, so it's going to be S is equal to DS, like that. Let's remove this. It looks a bit clunky that, doesn't it, with the double equals. Let's try it, no syntax errors. Let's check this guy. Oh yeah, it hit save. Let's see. Clear, yeah, no syntax errors, that's fine. Right, let's print them all out now, shall we? It's one thing I found that I sort of do that before I kind of finish the function. I found myself kind of running the code, for things like syntax errors and stuff like that. Okay, we've done it. 1, 2, 3, 4. That looks okay. Yeah, that's good. That'll work. I'm just going to lift the whole function out. Yeah, there we go. Let's see if this accepts it. Okay, passed, and submit. Admittedly, I'm doing this quite late at night as well. It's a long day. We've been climbing, we've been running today, but it's quite nice to actually. I thought this one was very easy. A long day, so it's nice to do some easy challenges at the end. See what our next question is here. Okay, basic calculator. I'll make this our last question, shall we? So, create a function that takes two numbers and a mathematical operator. So what are our choices? Plus, minus, divide and multiply. And performs a calculation on the given numbers. Okay. So effectively really big if, elif, else. Okay. Right. Not the nicest looking questions, but it's practicing the syntax, and if you're trying to get better at Python, sometimes you're writing stuff you don't particularly think cool and look very nice. It's not a very sexy question, but yeah, let's give this a go, shall we? Okay, and there's an interesting test case at the end here. Let's see, if the input transfer is divided by 0, return. Okay, so we'll be aware of this edge case. So I think what we'll do, let's see. Yeah, we'll do a try and except for this here. So I think for the time being, yeah, we'll just kind of do like an if else to go through this here. So we'll basically look at our middle operator, which is operator, or middle argument, which is operator, and then just do the appropriate one. So we do operator here is equal to, let's do them in order, plus, yeah. If the operator is a plus, let's see, return, number one. I'd probably do a lot of copy and pasting on this one, to be honest. I know it's a bit lazy, but and to be honest, you could do this like a super fancy like ternary thing. So you could do like return this plus this if else, and it gets a bit hefty. And sometimes writing it in the simplest way is okay, and that's fine. There's no problem with that. So we've got plus, minus. I'll do plus, minus, and multiply, and we'll come back and do the division one at the end, just so we can kind of make way for that edge case we got to do. Elif. I'm going to copy you. I'm going to put you here, and then that's good. Okay. So multiply, subtract, and I think here we'll do, now you could do an else because of course there's only one possibility, but I don't like the idea of that, especially in practice. It's kind of ingrained from this working in the industry, is like you can never entirely trust what your function is going to receive. So we're going to be explicit and say, okay, we're expecting, a division to come in here. So yeah, that's why I'm not doing an else at the end here, because I want to say, only try and do this, and you will only try and do this division if you get it. So yeah, I think it's a bit more wise in my opinion. So this is all of this happening here, and this is the case you've got to worry about, because that's where effectively something could do like a divide by 0. So why don't we pass this in as is? We'll let that test case fail where it's doing that division by 0, and then we'll fix that ourselves. Okay, that's the one here. So that's the last one which failed. I'm just going to see what it's expecting. It's expecting this here. So what you could do, so we want to do this here. To be honest, just do that. Just try and do it, except a 0 division error, and if that occurs, return this. Yeah, that'll do it. Make a bit of space. There we go. Look at that, and check. Hopefully it's happy with this. Yeah, look at that. Test passed. Cool. Yeah, I enjoyed that one. Actually, I didn't think I'd enjoy that big if, elif, else sort of stack. That was quite easy. Yeah, I think we'll end it there. As I said, yeah, it's been a long day today. There's been climbing, there's been running happening, there's been all sorts of work on a Saturday as well. But yeah, I do these quite often. It's a nice way, especially late at night. What time is it now? It's 9:20, so it's quite late at night. But it just keeps your brain fresh. Even after 10 or so years of Python, it's kind of cool to look at some trivial things, have a go, and just kind of get back to enjoying the basics of the language again. As I said, guys, I'll leave the link to that site in the description. If you want to just try some basic practice, it's pretty cool. Next videos, I might focus on, of course, some of the harder stuff, maybe some of the classic LeetCode ones, show you how I'd go about doing those. But yeah, cheers for watching, guys, and see you next time.